Okay, I can just put it in the pocket.
Yeah, it's working.
Good to start. Hello, everyone. I think it's time to get started. Thanks for staying back for the almost last talk. I think there's lightning talks after this. My name is Kashyap Chamarthy. I work as part of OpenStack Nova engineering at the moment, but I began as a test engineer a few years ago at Red Hat. Today, I'll talk about what kind of debugging utilities lower layers of virtualization have to offer when you're trying to deploy OpenStack or when you're debugging at an OpenStack setup. So especially when you have multiple, in any non-trivial deployment, you have lots of compute nodes, thereby multiple libvirt daemons and QEMU instances and so on and so forth. So let's get started. And then after that, we'll see a small real-world example of that ties together some of the things that we've discussed at the end. So why? As I mentioned, why this talk? So when you're debugging a large system like OpenStack, often virtualization drivers is where you may end up, not often, maybe sometimes you end up while debugging problems, say for instance live migration. There could be n number of flows that's possible with live migration. So that's one of the complex areas where things can go wrong in a subtle manner. So to find relevant log patterns and could become complex and cumbersome when debugging this. So let's see, what kind of bugs? Well, you're all well aware of plenty of different kinds of bugs that's possible. Crashes, things that occur only under a load. I linked a bug there. That's one of the notorious bugs that shows up in OpenStack Nova infrastructure, their CI infrastructure only. However much we tried to debug it independently, we just couldn't reproduce it. It's an interesting bug. If you're curious, you could take a look at it after the talk or later sometime. Then OpenStack CI infrastructure runs about 800 test jobs per hour. It's not a joke, it's real. You can see the URL at the end that shows you what kinds of jobs it is running. So briefly about Nova. Who knows about Nova here? Almost everybody. Okay, for the one or two who are not familiar with it, it's essentially the compute part of OpenStack, which is responsible for creating the disk image, calling the relevant virtualization driver, responding to calls to monitor the state, and etc. So it supports multiple virtualization drivers, as you could guess. KVM and QEMU are the default open source drivers, and multiple other drivers are also maintained, like Xen and VMware, even LXC, and so forth. The config attribute you see there is part of Nova's configuration file, where you specify the virt type and a bunch of other libvirt specific configs. Quick tour of KVM virtualization building blocks. Most people are very well aware of this here, but for those again who are not here, who are not familiar with it, a quick idea. KVM, as if you were at Mikhail's talk, he mentioned how do you enable KVM and how do you do that in BIOS. Maybe not BIOS, but general idea. So it's a kernel module. You have Intel's VMX and AMD's SVM instruction that allows you to perform hardware virtualization. And QEMU is a device emulator that allows almost 17 that emulates about 17 CPU architectures, and it does all the disks and network and display devices. So if you want a complete PC-like environment, QEMU is the thing that is doing all the heavy lifting. The two commands you see there, they just, if you run them, it will enumerate what kinds of devices it emulates and supports. And the second one, this dash CPU, it lists what kind of CPU QEMU emulates. And QEMU interacts with libvirt via the QMP JSON RPC protocol, so via a socket. So when libvirt is talking to QEMU, it constructs QMP commands and talks to it over this JSON RPC interface. And libvirt, as you've seen in the previous sessions, is the hypervisor agnostic library that allows you to manage multiple different hypervisors. This is just a silly ASCII diagram that shows the same things that we've discussed a few minutes ago. Okay, let's see a quick couple of things that are available in Nova utilities for debugging. As I've mentioned a few minutes ago, when you request Nova to create an instance, so it gets a call, it calls the API, and then the scheduler tries to place the instance among any number of compute nodes, and then the Nova compute process interacts with the libvirt virtualization driver, and that interacts with QEMU via the QMP protocol. Feel free to interrupt me, but when I see people around here, most of them are very familiar faces that I see who are deeply involved in virtualization. So maybe I'm preaching to the choir here. So Nova Compute, like any large project that you expect, it has these default flags that you can set in its configuration file that allow you to examine a bit more detailed flow of requests and track down where the issues are. And Nova also has this thing called Guru Meditation error reports that I'll discuss in a minute. Followed by that, libvirt has a few very detailed utilities that will let you examine a request in a very granular fashion. And the libvirt lock filters is one that will let you do that. We will discuss that also in a few minutes. And the libvirt shell wrapper virsh tool as well. Followed by that, for QEMU, the QMP commands and HMP commands are two of the things that you can use to live query or modify a guest state, but modifying the guest state behind libvirt or the higher management layers back is really frowned upon because it voids your support warranty. When debugging, I personally do use the QMP commands because libvirt uses the QMP interface, so I just make my eyes tuned to looking at the JSON blobs of QMP commands. And KVM, well, this talk is mostly about libvirt and QEMU, but for KVM there's a talk link that I have at the end in the references, so that could be, that's a very nice talk if you want to dig a bit more deeper. So this is a bit out of scope for this talk. So yeah, Guru Meditation report, until this was available, there was no way to get a proper error report if you want to kill a Nova process and see get state of a live Nova process like the API process or the compute process. So one moment. With the introduction of this Guru Meditation report, you can now supply a user-defined signal, either USR1 or SIGUSR2, and give a process, so that it can to the kill command, and then it will immediately generate a large report that can be examined. Good question. The question is this signal specific? Is this error report mechanism specific to Nova or other components? It is currently wired up in Nova. there is work in progress to enable that in other projects as well, but I'm not tracking those efforts. So probably they're already, some of them might have already been merged. So we can check that from the Git. So earlier the signal used to be SIGUSR1, but it turned out that some Apache process reserved the SIGUSR1 signal, so we had to change the default signal to SIGUSR2. So from the next upstream OpenStack release onwards, the signal to use is the USR2. So yeah, that's just a brief rundown of what kinds of things that you see in the error report of Guru meditation. There's a link at the bottom that you can refer to that shows what kinds of things that it enumerates. The most useful thing is the configuration detail. Sometimes people, when report bugs, or if you're using a downstream product, when customer reports bugs, they say they've enabled so-and-so thing, but oftentimes it turns out they didn't. So just so that you can get, to eliminate that bottleneck, you can get the configuration details now when you generate this error report framework. By the way, if you're wondering about the Guru meditation quote, the phrase, it's apparently for old Commodore machines when they crashed, that they used to generate such an error message. So it's an origin from there. This was written by, this Guru meditation report framework in Nova is written by my colleague Daniel Beranche. And the nice thing about this is you don't need to have, you don't need to set up anything or configure anything to trigger this. So no action is necessary from the operator. So let's see what kinds of debugging controls that libvirt and QEMU offers. Most often, the first thing that you have to look at is the virtual machine specific logs that are located in varlog libvirt / QEMU, followed by the instance name, instance log, and that contains mostly the libvirt generated QEMU command line, followed by the error messages from QEMU. So that's a useful place to look at if you suspect there is any QEMU issue when you're debugging from a higher management layer. So from then on, you might get further clues by enabling log filters, so on. And libvirt's standard error string is also redirected to the log file. Yes, a few minutes ago I mentioned about the libvirt log filters. So that allows you to examine the libvirt log file at a more granular fashion. So three main things that libvirt has is log messages, log filters, and log outputs. So filters is just essentially a set of patterns and priorities that you tell the libvirt daemon to log. For instance, if you want to capture only things related to QEMU driver, you can specify, hey, please only capture debug priority for the QEMU driver and error/warning messages for the rest of them all. So that's just that's how you enable it. You supply these config variables in libvirt's libvirt daemons config file, and you restart the libvirt daemon, followed by triggering a test from the beginning, so you can see what's going on. That's for daemon logging. You could also examine what kinds of public API calls that libvirt is issuing by setting some environment variables on the command line. And you could see a few environment variables listed there. You could redirect the output either to a specific log file or to systemd journal. Either of them would be fine, or you could set to both of them as well. And this applies also for the libvirt daemon as well. So, yes, for when you use systemd journal, it has very nice structured fields that will allow you to examine what function the error is coming from, what code line, what error code, and what kinds of which source file. Very granular detail you'll get when you use the journal CTL to query. Yeah, these are just a couple of examples that you supply to the journal CTL tool. You say, journal CTL, please enumerate all priority. The last command, for instance, if you see, please enumerate all error priority messages for libvirt daemon since today. So that's very convenient and a useful tool in the toolbox. Two other very interesting commands that QEMU allows and that you could run via libvirt are the QEMU monitor command and QEMU monitor event. So QEMU monitor command that will just allow you to pass through any QMP commands that you can run via this invocation, so that you can inspect the live state of a VM or modify it if you're in a very deep debugging environment. But oftentimes you just want to inspect a state of a VM. We'll see a few commands next, what kinds of things are available. And there are a lot more utilities that libvirt offers that you can check out in the manual page of libvirt. Yeah, so if you run a QEMU monitor command this way, you just apply the VM name followed by a flag pretty that will just print the JSON output in a readable fashion, and you say, please execute the query command that will enumerate all possible QMP commands that QEMU offers, and you can run via libvirt. So when you run that, you see something like an output like this. But I just trimmed off a lot of output. There are about 170 or 160 commands. So one of the commands that I highlighted there is the drive mirror command that we'll get back, which is used for storage, live storage migration. We'll get to this. Sorry. Another command that's useful is not useful. That's just an example. To query, it's also useful. To query live block block information of a VM. So if you run this query block, it will show all block device information of a disk image of a VM. So if there is a backing file, most often all OpenStack instances, Nova instances, will have a backing file. So you'll see information about the backing file, the virtual sizes, and some of the IO ops related information, and so on. I trimmed off a lot of output, but if you're debugging anything related to block layer or just wanted to see what kind of detail that's going on under the hood, you could invoke this one. So the monitor event command, you can see various kinds of events. For instance, if you're performing a live block operation like a disk copy or live migration, live storage migration, you can enumerate, you can invoke this command, and then parallelly, while the disk copy or live migration is going on, you can see the events that on your shell where you invoked the QEMU monitor event. You have to run it in a loop so that as long as the command is running on the other shell, you can see the events that are in progress. And you can observe all kinds of arbitrary QEMP events that you can see what kinds of events are possible by running the QEMU monitor command followed by query events. So it will enumerate all events that are possible. So enough of rambling about what kinds of tools are available. Let's see a small example of how do you trace the flow of a guest crash during live block migration. When I was trying to prepare this presentation, I encountered this bug, so I thought, why not use this as an example for this? So first, why this example? Like I mentioned at the beginning, when you were doing any non-trivial deployment, you have to interact with multiple compute nodes and multiple libvirt daemons. So this is a nice example where a live block migration is happening, which means along with the guest state and the device state and memory state, you are also copying the disks to the destination. So that's what's happening when you say block migration. And you can examine what kinds of commands libvirt is constructing to send to QEMU. libvirt is asking QEMU to construct and send them to the destination daemon. So this is a nice example if you want to see the flows between source and destination libvirt and QEMU instances. So when you want to perform a live block migration from Nova, you just say Nova live block migrate followed by the block migrate flag, and you specify the instance name and the destination. Once you do that, there are a bunch of flags that Nova sets to configure the block migration, and it performs it. By the way, as a small digression, these flags will now be deprecated in Nova, but it will retain the functionality just so that it's confusing for users and operators to set up all these flags. So it's just easier to eliminate this and then do the right thing by default with a tri-state flag that will handle various configs with a single configuration. So up until now, you have to explicitly set them. There are some default flags, but you can set something specific based on what kinds of things you're doing. Like if you want encrypted tunneling, there is a specific flag for that. So yeah, that's in brief. That's what happens when you trigger the live migrate command. And if you want to see what's happening underneath, a good way is to use the libvirt shell interface and supply the same flags that Nova is asking libvirt to construct. So that's what you see. You say virsh is the shell interface of libvirt. Say migrate followed by the verbose flag and incremental storage flag. That means a base image is shared, same base image is shared between source and destination, followed by a peer-to-peer flag, which implies the source libvirt daemon will control the complete migration flag. If I'm wrong, please correct me, Mikhail. Yes. So,
you are running the migration command instead of Nova Compute?
What is that? Can you repeat that?
You are running the command instead of Nova Compute, so you're actually duplicating what Nova Compute.
Yeah, this is just to see what Nova. If you run the Nova live migrate, I didn't show the Nova logs, Nova specific log when you invoke this. This is just a way to enumerate what you can run with libvirt instead of Nova.
No, but that's exactly what I'm looking for. So in Nova logs, you can see the...
Yes. In Nova logs, you can see what calls are being done. If you see, it's just the same interface. It is using the same APIs that Nova is calling. So it's calling the equivalent Python bindings, though. So the libvirt Python project is what used. And the specific API is the migrate to URI API that you see at the bottom. So that's in short. Yes, and when you do that, and the libvirt standard error stream says, guest unexpectedly quit. That doesn't give us much information what's going on. So let's see further what else we can do. We can examine the libvirt daemon log and see what else is available. There is an error message that says internal error and end of file from monitor, which again doesn't inform much if we are coming from higher level management project like virt or OpenStack, some other projects like that. If you scroll further down, you will see a bit more verbose error message that says VM1 closed without shutdown event, and I'm assuming the domain has crashed. But you don't know whether it really crashed or not. But if it assumes, we are not certain if the assumption is true or not. So let's see if we can confirm the assumption. As I've mentioned a few minutes ago, the virtual machine specific or the Nova instance specific log is located in the varlog libvirt QEMU directory. There you could see a cryptic message that says coroutine and re-entered recursively. Again, that really doesn't say much either. So let's see, and then the cache is shutting down there, you could see. So let's see how much further we can drill down. Because libvirt said guest crashed, we could examine if there are any cordums available. So we could use a journal, systemd journal tool like cordumctl to see if there are any cordums present. We could see that indeed there is a cordum available for QEMU process. So here we confirm the libvirt assumption. If you have all the necessary debug packages and all relevant dependencies involved, you'll get a nice core that you can dump via the cordumctl command so that you can extract contents like stack trace from it. So if you're providing a bug report to a lower layer project like QEMU or libvirt, so this is one way to go where you can provide as much detail as you can. And you can also see the segue signal, which is a segmentation fault that the cordumctl outlines clearly. So at this point, we know that the bug lies in QEMU. So, and we could report this detail in a bug, and which is quite informative. You don't really have to do anything more because it's more or less self-contained bug report with this level of detail, which a QEMU developer should be able to act. And the said QEMU developer is sitting right there who fixed it, Kevin Wolf, this turned out to be a bug in a QEMU's disk mirroring code. When I filed the bug, I was looking through the Git source code to see the relevant error messages, if there is any hints for that. So when I was looking at sorry?
So there's no ABRT integration?
Well, yeah, good question. There is no ABRT. Is there any ABRT integration? ABRT is automatic bug report tracking tool to those who haven't heard. Well, there is, but I didn't enable it on my system, so probably I didn't automatically report. So I filed that bug. But yes, I don't trust as much the ABRT report. Maybe I should. This will be recorded. So, sorry. Often? Yeah. Okay. So yeah, so that's one small example that outlines that tools and utilities that we could use to track down bug. It's not really necessary if you're working at a certain management layer to dig down. If you could file the bug to the respective component, the respective engineers might track it down. But it's always nice to dig down deeper and then try to find out the root cause as much as we can. So that was the failure case. In a successful case, to understand what's going on behind the scenes, you could grep through the libvirt daemon log to see what kinds of commands libvirt is asking QEMU to construct. So you could see the drive mirror command. If you were paying attention a few minutes ago, we've seen the drive mirror command when we enumerated a list of commands via the QEMU monitor command. This is where you could see the invocation that source libvirt daemon uses to talk to the destination, where there's an NBD, a network block device server running, which is taking all the data that's sent from source libvirt daemon. So this is on the source host that I grepped for. Likewise, you can do that on the destination and see what's going on there. So a few references that I said at the end. Last year at KVM Forum, there's a nice talk by David Hildenbrand on guest operating system debugging that goes into much more detail about using GDB, and more lower layer debugging. And there's another one by Stefan Hanossi, also last year FOSDEM, on observability in KVM. So it's also a very nice talk. So if you're interested in digging there, you can check that out. Yes, a few days ago I was at FOSDEM, and I attended a talk. Some of my colleague referred, said you should check out the talk called "Hunting the Bug from Hell," where Andrew Halley, a free Java developer, said something very interesting, where he outlined the most complex bug he has ever fixed, and he set the stage by describing the problem statement, and then giving some hints as to if anyone in the audience can guess it. Very well engaged talk, maybe unlike this. His essential point at the summary was a lot of us spend time debugging, and not much is written or shared about it. So I thought it was a very well said point. So there we are. That's all I've got. If there is any questions, there are any questions. But I don't know. Most of them are experts here who are sitting. All right, there are no questions, and thank you.